Welcome students for online lecture on fluid power systems. We will start with introduction to fluid power systems. Before that, we will go through the syllabus contents of all 5 modules. First module is introduction to fluid power systems. So in first module we are going to study components which are used in fluid systems, advantages and application of fluid power systems, transmission of power at static and dynamic states, Pascal's law and its applications, fluid for hydraulic systems, types of fluids, properties of fluids, and how to select the fluids, like different types of additives, effect of temperature and pressure on hydraulic fluids, different types of seals, sealing materials, compatibility of seal with fluids, types of pipes, types of hoses, and different types of quick acting couplings, pressure drop in hoses or pipes, fluid conditioning through filters, strainers, source of contamination and contamination control, how to control the contamination, different types of heat exchangers to control the temperature of the fluid. So these things we are going to study in module 1. So in module 2, that is pumps and actuators, classification of pumps, pumping theory of positive displacement pumps, construction and working of gear pump, vane pump, piston pump, fixed and variable displacement pumps, pump performance, characteristics, pump selection factors, how to select the pumps for the given application, problems on pumps, accumulators, types, different types of accumulators, how to select the accumulators. So what are the application of the accumulators, types of intensifiers, pressure switches, pressure sensors, temperature switches and temperature sensors, and lever sensors. So different types of actuators which we are going to study are single acting cylinder, double acting cylinder, how to mount the cylinders, what is meant by cushioning, why the cushioning is required, special types of cylinder, problems, construction and working of rotary actuators such as gear motor, vane motor, piston motors, theoretical torque, power and flow rate, and hydraulic motor performance. And we are going to solve the problems on different types of motors, and we are going to see the symbols which are used in the circuit diagrams for all the components. So in third module we are going to study the components and hydraulic circuit design. So different components we are going to study here: classification of control valves, direction control valves, symbolic representation, construction of features of different types of valves such as poppet valve, sliding spool valve, rotary type valves, solenoid and pilot control valves, diet operated types and pilot operated types valves, flow control valves, compensated and non-compensated flow control valves, temperature compensated valves, pressure compensated valves, and different symbols which are used for the components to show in the circuit diagram. So all the components we are going to show by the symbols while drawing the circuit diagrams. For given applications we are going to design the hydraulic circuits, and in that hydraulic circuits we are going to use all the symbols of components. Hydraulic circuit design for the given application, it may be a punching job, or it may be a sheet metal cutting work, or it may be assembly work. So it may be a moving of the heavy loads, or it may be a moving of the tools, or it may be a moving of the components, maybe clamping of the components. So for different applications we are going to design the circuits according to the given applications. So here we are going to study meter in, meter out circuits, bypass circuit, synchronization circuits, sequence circuit, counterbalance circuits. So different types of circuits we are going to design for different given applications. So here we are going to study how to design the circuits. So in module 4, that is pneumatic power systems. So first is introduction to pneumatic system, pneumatic power system, advantages, limitations, applications, choice of working medium, characteristics of compressed air, and different types of air compressors which are used, structure of pneumatic control system, fluid conditioners, dryers, and fluid filters, regulators, and lubricator unit. We are going to study different types of actuators which are used in pneumatic system, like in hydraulic system. Here also we are going to study different types of cylinders which are having linear motion, and different types of motors, linear cylinders, types of cylinders, working and position cushionings, types of seals which are used, how to model the cylinders, rotary cylinders, types, construction and applications. In pneumatic control valves, directional control valve, we are going to study poppet valves, spool valves, suspended seat type valves, pressure control valves, flow control valves, type of construction, use of memory valves, quick exhaust valve, time delay valve, shuttle valve, twin pressure valve, and we are going to see the symbols for all the components. In module 5, that is pneumatic control circuits, simple pneumatic control, direct and indirect actuation, pneumatic cylinders, speed control of cylinders, signal processing elements. We are going to use the logic gates, and or NOR, NAND, multi-cylinder applications, coordinated and sequential motion control, motion and control diagrams, cascading methods, and we are going to study electro-pneumatic control, pilot assisted solenoid control of directional valves, use of relays and contactors, control circuitry for simple single cylinder. Fluid power systems. The basic source of power in industry comes from three kinds of source: electrical, mechanical, and fluid power. The use of electrical prime movers such as electric motors and mechanical prime movers such as internal combustion engines is very common. Also, the means of power transmission in this system is well established. For example, the electrical power is transmitted through the suitable power cables, while the mechanical power is transmitted using gears, shafts, belts, etc. The third common source of power that is widely used in modern industry is the fluid power. High pressure fluids, both liquid and gases, can be used to transmit power from the point of source to the point of utilization, which in turn can be used to produce rotary or linear motions. And the special application of fluid power is to apply a force onto an object and release the force. It is possible to apply force through some mechanical means. Fluid power is the most convenient way. Fluid power systems that use liquids as the working medium are termed as hydraulic systems. Fluid power systems that use gases are termed as pneumatic systems. Fluid power refers to the branch of engineering that deals with the use of high pressure fluids with confined areas to generate, control, and transmit power. That means it can act as prime mover, control industrial machine motions, and transmit power from one point to another for useful purpose. So let us see the components of fluid power systems. So different components which are used in hydraulic systems are reservoir to store the oil, filter to filter the oil, next pump. To run the pump we require the electric motor. So electric motor is coupled to the pump. So when you start the pump, when you start the electric motor, the pump will starts to suck the oil from the reservoir and it is delivered to the system. And the oil which is pumped, it will flow towards the pressure regulator, pressure relief valve. From pressure relief valve, it will move towards the direction control valve, and from direction control valve, the oil is going to move through the actuator. So after doing the work in the actuator, the oil is going to return to the reservoir passing through the direction control valve. There are 6 basic components required in hydraulic system: a tank or reservoir to hold the hydraulic oil, a pump to force the oil through the system, an electric motor or other power source to drive the pump, valves to control oil direction, pressure and flow rate, an actuator to convert the pressure of the oil into mechanical force to do the useful work. So in actuator only we are going to get the work done. So after completing the work in the actuator, the oil is going to return back to the reservoir. Piping to carry the oil from one location to the other. So we are going to making use of pipes to move the fluid from one point to another point. So tank, pump, electric motor, valves, actuator and piping is the components of hydraulic system. So we'll see the components of pneumatic system. So compressor is required to compress the air, filter is required, the air is going to pass through the filter next to the compressor. To run the compressor we require the electric motor. Next when the air is compressed, this pressure is and the temperature is going to increase, and to cool the temperature, to cool the air we require the air cooler. So after air cooler there is a reservoir. So from the reservoir the compressor is passed through direction control valve, and from direction control valve to the actuator, and after doing the work in the actuator the air is exhausted in the atmosphere. So along with that we require the pressure switch to control, to stop and on the motor. So these are the components of pneumatic system: compressor, electric motor, filter, air cooler, pressure switch, air reservoir, direction control valves and actuators. There may be linear actuators or there may be a rotary actuators. So pneumatic system have components that are similar to those of used in hydraulic system: an air tank to store a given volume of compressed air, a compressor to compress the air that comes directly from the atmosphere, an electric motor or the other prime mover to drive the compressor, valves to control the air direction, to control the pressure and to control the flow rate, and next piping to carry the pressurized air from one location to another. So these are the components of pneumatic system. Advantages of fluid power system. The advantages of fluid power system are as follows: fluid power systems are simple, easy to operate and can be controlled accurately. So the movement of it may be a movement of the tool or it may be a movement of the component, so we can control accurately by using the fluid power systems. Fluid power systems are simple, easy to operate and can be controlled accurately. Fluid power gives flexibility to equipment without requiring a complex mechanism. So no need of complex mechanism here in fluid power systems. Using fluid power we can start, stop, accelerate, decelerate, reverse or position large forces or components with great accuracy. Accuracy is more here, using simple levers and push buttons. Multiplication and variation of force. Linear or rotary forces can be multiplied by a fraction of a kilogram to a several hundreds of tons. So for if the load on the actuator is less, then also it can be used. For heavy loads also it can be used. So easily we can multiply the forces. Multifunction control. A single hydraulic pump or air compressor can provide power and control for numerous machines. So by using one same system, we can control a lot of machines. It may be one machine, or it may be 5 machines, or it may be 10 machines can be controlled easily. A single hydraulic pump or air compressor can provide power to and control the numerous machines using valves, manifolds, and distribution system. Low speed torque. Unlike electric motors, air or hydraulic motors can produce a large amount of torque while operating at low speeds. So at low speeds also we are going to get high power, high torque, constant, and we are going to get the constant torque. Fluid power system can deliver constant torque or force regardless of speed changes. Economical. Not only reduction in required manpower, but also production or elimination of operator fatigue. So it will remove the operator fatigue also. As a production factor is an important element in use of fluid power. Low weight to power ratio. The hydraulic system has a low weight to power ratio. We are going to get more power to the weight. Low weight to power ratio. Power is more and weight is less compared to electromechanical systems. Fluid power systems are compact. So if you compare the size of the electric motor and hydraulic motor, the hydraulic motor is very compact. Fluid power systems can be used where safety is of vital importance. Safety is of vital importance in air and space travel, in the production and operation of motor vehicles, in mining and manufacture of delicate products. So fluid power systems can be used where safety is of vital importance. Applications of fluid power. There are wide variety of applications of fluid power systems. All engineering industry. If you take any industry, there we can go for hydraulic systems or pneumatic systems. All engineering industry use fluid power for operation and machine tools, loading, unloading operations, automotive and aerospace sectors, earth moving equipments like JCBs, building construction machineries. In building construction machine also we can go for hydraulic systems. Robots of modern days. So in moderns also we are going to use the fluid power systems. For the gripping of the job, it may be a movement of the levers. Robots of modern days make extensive use of fluid power systems. A brief list of applications of fluid system is hydraulic jacks for raising the heavy loads, steering mechanism and braking mechanism in automobiles. In robots, movement and control of various arms to control the movement, control of various arms. In welding equipments for movement of electrodes, in power presses for sheet metal and forging operations, in hydraulic powered cranes for lifting and moving the heavy items, in earth moving equipments, in press for assembling the parts. So still there are number of examples or applications we can see in our daily life in various type of industries. Pascal's law. Pascal's law relieves the basic principle of how fluid power systems perform useful work. This law can be stated as follows. Pascal's law states that the pressure applied on a confined fluid is transmitted undimensioned in all directions and acts with equal force on equal areas and at right angles to them. So the pressure of the fluid is acting perpendicular to the walls and it is same at all the points. The Pascal's law states that the pressure applied on a confined fluid is transmitted undimensioned in all directions and acts with equal force on, on equal areas and at right angles to them. The above figure shows how Pascal's law can be applied to produce a useful amplified output force. Consider an input force of 10 Newton is applied to a 1 meter square area piston. This develops 10 Newton per meter square pressure throughout the oil within the housing, that is the confined fluid. This 10 Newton per meter square pressure acts on 10 meter square area piston, producing 100 Newton output force. So this output force performs useful work as it lifts the 100 Newton force. So one side we are going to apply the very less force, but we are going to get the high force in another side. So next things we will discuss in the next class. Thank you.